Hey guys, welcome back to another video, and oh, this desk isn't in the same place, is it? Oh, that's a 3D printer over here. What's going on? So a couple months ago, I got a job in aerospace engineering working for a company down here, and I moved out here, and yeah, that's where I've been. All right, so we're gonna do a fleet update here. We've got the Efflux down here, the 81. We've got the little 3D plane, although I stole some servos off of it. I got the Scimitar, and over here I got the Cormorant 2. I don't know if I've ever showed these guys on this channel. I got a Orlando Hunter 1/32 scale XO2, I think it is. I put a brushless system in this, and I had to make a custom transmission, and it keeps breaking. So the transmission on this one is currently down. And I got my little trusty Micro T that I've had for like probably 10 years. I converted it back to 2S brushless after running on 3S for forever and continually breaking things. And it's been much more reliable now, although it is starting to make a weird transmission noise, so I'm grounding it until I can take a look into that. I got this boat that I got from my grandpa, and it runs great, and I put brushed motors that are way too powerful in it, and so I had to put cooling jackets on them. And now I'm basically just looking for a pump that won't get clogged up by seaweed and stuff. I've been using like those little diaphragm pumps that come with a 360 size brush motor, and the diaphragms, the valves in there always get like clogged up with little bits of sand and seaweed and stuff. Down here, we've got my Traxxas Summit, which I've had for forever. I painted a new body for it, and I haven't had a chance to run it with it because the RC track has always been wet. Yeah, it has I put a Castle Mamba Monster 1/8 scale system in it over the summer, and it rips really hard. This guy right here, I got this recently. My previous 3D printer was a PrinterBot Simple 1405, and that thing was a tiny little 3D printer. It had a 4-inch cube build volume. And this thing has 8 times the build volume. It comes like pretty much entirely assembled, whereas the PrinterBot was like, you had to build the entire kit yourself. I stayed up, like, pulled an all-nighter to do that. That was fun. And then this thing, it has a heated bed too, and it like just works. You just plug it in and you load up the print configuration settings on there, and it like does all the auto leveling and stuff for you. You don't have to do any tuning. Overall, very, very impressed with this thing and the quality of it. Like, it's built out of aluminum extrusion here. Like, it's real stout. It's got a lot of heft in this, and it's insane to see how much you can get for like $200 plus $50 in filament these days. 3D printers sure have come a long way in the however many years that I've been out of them. The reason I got this guy is because I got myself a Traxxas Slash. And I got this thing as a sliding chassis without any of the suspension hubs or the shocks. This is a 2-wheel drive Slash, and I wanted to take the motor from the Summit, the old Titan 775 and EVX2, and I wanted to put it in here just because, you know, I have a spare motor in ESC lying around with nothing to do with it. And I wanted to use the 3D printer to put front brakes on it, so that's what I did. This body I painted by myself, by the way. I think it turned out very nice. I started off with I was gonna do a gradient from like a white to sort of a light blue in the back here, but when I put the white on, it sort of got all splotchy, and so I just ended up flicking a bunch of white paint on here. And the blue, I actually sprayed some red behind it, so it turned this sort of nice purple. I think it's really snazzy. You could already see I've beat it up a little bit driving it on the road. Here it is. You can see it's not quite the same as your normal Slash. We'll start up in front here with the brakes. So these are made up of 2 parts. You've got this sort of bracket right here that holds the servo. It clips around the front of the steering knuckle there, and then it's secured on the bottom by this bolt through the steering knuckle. So it goes through the knuckle, through the ball joint here, and then it comes out the other side, and it goes through the bracket, and then it's got the nut on the end. I had to get longer screws for that, but worked out pretty good. Just went to the hardware store. And then the second part of this is just the brake shoe itself. So you can see this is a separate part that pivots. It has a little pivot point down here, and that's a screw from the backside. This is just this brake pad materials, I think it's 1/16 inch like plumbing gasket material. I have this CA glued onto the brake shoe, and then on each end I just put a little screw in there to make sure it stays on. These servos here are like Emax micro servos. I think they're the Emax ES9251. I had ES9051s in there, but those aren't rated for 6 volts. I didn't know this put out 6 volts, so I ended up burning those up. So that's what I stole off of the 3D plane up there. One of the hardest things was just finding out where to clock these around the sort of wheel to get them to properly fit with all the suspension movement and everything. Because you can't really put them behind here, because when you go like this, they would get crushed up in here. And then you don't want to put them on the bottom, because they would, I mean, they hang out of the actual wheel. So if you put them on the bottom, they could easily get hit by whatever is coming this way. So it had to be above the lower arm here, and it had to be able to not hit anything at all suspension, deflection, and steering angles. And so this is literally the only place you can put them. So they come real close to that upper link there, and then on the bottom here at full extension, they're like pretty much touching the lower control arm there, but they're exactly in the right place. I did do this is the second revision of these brakes. The first one I had the brake pad turned around so that it was like self-engaging, self-locking. That's how they are in actual real cars, but at this scale they just tended to jam. They would inadvertently apply themselves, which is not very good. When I did brakes on my XB70, I had a similar problem. They would engage real nice, and then they wouldn't disengage. So you can imagine, sort of as the wheel goes around forwards, it's pushing this brake pad away from the wheel, whereas if the wheel had been, I guess, going backwards, or if the brake pad had been reversed relative to the wheel, then it would tend to bite here, and then it would cantilever out on this and self-engage into the wheel. And I should also mention that these are just running on the inside of the stock wheels as drum brakes, basically. And then we've got all of our wiring and stuff. Oh yeah, this roller also had the light kit from Traxxas, so that was pretty neat. I wanted the brake lights so that I could do brake light things, because I thought that would be fun. And also, I sort of like these because they sort of match the aesthetic of my Summit. I have the light bar up there, and so it just sort of felt right. Moving further back, we have this double high battery strap thing. I got one of these off of eBay that was also 3D printed. It was a bit less stout than this one, and these little tabs at the back weren't quite long enough. And so when I would go for big bumps or something, or otherwise jostle the car around, the rear tabs would come out, and it would allow the batteries to sort of flop around. So I had to make my own. And then we've got our cool little avionics box here. I'm actually not sure if it's proper to call this an avionics box. I don't know what you'd call this, because it's not a plane, so maybe like electronics box. But anyways, we've got an Arduino down here that's doing all the control stuff. It's got a little capacitor here for 5 volt, or I guess it would be the 6 volt rail filtering. It's got a bunch of outputs for the brake servos, as well as the lights. So it controls the brake lights, the front lights are always on, and then it controls the brake servos. It also has inputs for steering and throttle off of the receiver, and the aux channel off of the receiver. So there's still some functionality I could potentially get out of this that I haven't yet, but currently I have it set up. Oh, there's also these potentiometers down here. So these two are used for adjusting the left brake, these two are used for adjusting the right brake. The top one is brake engaged, and then the bottom one is brake release. You just screw it in to tighten the brake, and screw it out to loosen the brake. I think these are like 10-turn, 10K potentiometers. I have this other one that I'm not using currently. I think I might set this one up as like a brake bias or a dual rate, so that you could dial down the brakes or turn them up, because depending on what surface you're going on, you might need more or less friction to lock up the wheel. So currently I have the switch on my transmitter set up. It's the little rocker down by your thumb. I have it set up to disable brakes and then enable braking if I want to. So I can turn the brakes off if I want to experience the stock two-wheel drive slash abysmal braking performance. and just lock up the rear tires and go spinning off into wherever. I must say that the brakes really do improve, and you'll see I'm going to have driving footage after this. The brakes really do improve the stopping ability of this here vehicle. So in the future, I could do something like mixing in steering, so it would sort of act as a cutter brake. Like if I'm steering hard, it would lock up one of the tires and let the other freewheel to sort of pull me around a little bit. I haven't experimented with that as of yet. So then we can move further back. Here's the EVX2 from the Summit. And then here is the Titan 775. So this is an RPM transmission case. I have the 272R input shaft on the recommendation of people on the internet, because they said that the actual gear on the end of the shaft on the stock one will start to slide or slip or something over time. So I just got that because it's actually, there's two flats on the shaft, and then the gear has flats built into it, so there's no chance of it slipping. I have the 272R intermediate gear because I bought the VXL intermediate gear, but then I realized that it didn't come with the pin that goes between the two transmission halves that the bearings ride on, so I need the pin, and turns out that they don't sell the individual pin, or if they do, I just didn't find it, so I ended up getting the 272R intermediate gear. It has a stock slash differential in it, so it's just open diff at the moment, which is why you can see my tires whenever I go around a corner real fast and gun the throttle and this thing body rolls over. The inside tire just gets absolutely smoked on that inner edge. So yeah, I've been driving this thing on the road for a bit over a week, and these tires were brand new, and they're looking pretty bad. You can see the fronts are still, they got plenty of life left in them, but yeah, I might have to find some better tire compound, or I don't know if going to limited slip would, or like putting some heavier diff oil in there would help with it, but that isn't a sealed diff, so I might have to get the 272R sealed diff in there just to be able to run some heavier weight oil in it, because right now it just has grease. And then under here, you can't see it, but I'm running an 18 tooth pinion and a 56 tooth Robinson Racing slipper clutch. Those are mod 0.8, which I think is 32 pitch. And there's basically no adjustment as far as gear mesh on this, because the motor is like super tight in there, so you can't slide it forward or back or anything. I had to actually cut the transmission housing a little bit to get this thing to slide all the way in and fit properly, as well as like clearance little parts of, I think you might be able to see it around here. Yeah, I had to file down the top of this this rear bumper mount just to get it to to fit below the motor there. I also had to take the flux ring off of the motor. I've heard what this does is it gives you a bit higher torque at a lower RPM, so I guess I'm running higher RPM and less torque and less efficient, but I do have this heatsink on here, which it was a whole extruded aluminum bit, and then I cut it to fit what I have here, so it fits nicely around. I cut off so much meat on the actual bottom part of it that it doesn't really clamp anymore, so I actually put 2 screws in either side, and then I dimpled the outside of the motor with a drill bit, and so these just screw into there. I have Arctic MX4 thermal compound between these. It's just like a thermal paste for computers and stuff, just to improve the heat transfer. I have this little mount I designed, and the other side of that mount is over here. Let's go and get that. And then this is your sort of spacing simulator for a 60mm fan that will be going here, because the motor temps are all right currently with this current setup. Without the heatsink, they were getting pretty toasty, but I'm planning to increase the gearing. I'm going from 18 to 56 to, I think it's 30 or 31 to 80. The only slipper clutch I was able to find, the Robinson Racing ones, that was in that size. There's one for an axial Wraith, I think. That's an 80 tooth 48 pitch, and so I'm going up to 48 pitch. But the thing is, since you don't have any motor adjustment range, you got to keep the distance between the center of the gears constant. And so that really limits your gear choice, and whenever you change your pinion, you have to change the spur, unless you're changing your pinion like one tooth in the one direction that it's able to actually accommodate. And the reason why I'm going with that Robinson Racing slipper clutch is because I've had experience with my Summit that the stock slipper pads, the sort of 3-pad assembly, it just it'll throw one of the pads out. So the Robinson Racing one, it's got a proper disc of material in there, so you can't really break it, or it's not as easy to do so. So I've had good luck with their clutches on the Summit, and so I decided to get some for this. And then finally at the back here we have this little wheelie bar that I made. The car itself, from a standstill with the traction it has on pavement, doesn't actually have enough oomph on it to wheelie, but if you're going and then you jam on the brakes, the front will nose down like this, and then that rebound from the shock is just enough to get you back in the air if you gas it real hard. I made this wheelie bar after scraping the bottom of my chassis and the bumper a little bit, so you'll see that in some of the later clips. I have the wheelie bar installed and I'm sort of riding on it. This thing just clips on to these two little rails here, and then it's just got a mount for the bar there, and it's screwed in here. And yeah, I do have more airplane stuff coming in the future. Let's see, I have the combat wing for Flight Fest 24. I've got some ideas for that, and I've got some ideas for the Efflux Mk, which, I mean, I should really finish the test campaign for the Mark III, but I'm thinking about doing some co-flow wing stuff with the Mark IV. Now that I have a 3D printer, it would be fairly easy to design some ducting to go into some fan units that would sit inside the wing and then blow air from the leading edge, suck it in back at the trailing edge, and just repeat that cycle. And that could accomplish what the Mark II was sort of aiming to do, but the Mark II was limited because you couldn't have the circulation control and the propulsion active at the same time, and it didn't have enough thrust to fly on circulation control alone, so whenever you activated it, it was basically just a glider, so that really limited the data output you could get out of it in terms of speed and just controlling for steady level flight. Another part of that too is that you're dealing with a ducted fan platform, and those are notoriously inefficient, and so you could get like 3 minutes of data, not even 3 minutes of data, just 3 minutes of flight time out of each flight. So I think moving to a propeller-based design just for the efficiency and having a separate circulation control or co-flow system would allow me to get a lot more data on that and actually make better use of the flights that I was doing. So that's sort of the idea I have for the Mark IV. All right, I think that's about all I've got for you guys at the moment. And so I'll just leave you with a bunch of footage of this guy driving around. See y'all next time.